3, 2, 1. Wow. Hello everyone, it's October 5th. Meow. Alright, let's take a look. Sentence similarity number 3. You are given two strings, each representing a sentence composed of words. A sentence is a list of words that are separated by a single space with no leading or trailing spaces. Each word consists of only upper and lowercase English letters. Two sentences as one as two are considered similar if it is possible to insert an arbitrary sentence, possibly empty, inside one of these sentences, such that the two sentences become equal. Note that the inserted sentence must be separate from existing words by space. Return true if they are similar, false otherwise. So basically we're saying if one of the sentence we can insert a sentence, arbitrary sentence, such that the two becomes equal. So hello Jane and hello my name is Jane can be made equal by inserting my name is between hello and Jane. Frog cool. Frogs are cool or not, because although there is a sentence SR inserted into S1, it is not separate from. So basically if we split the sentence into array of strings, right? It's array of strings. So the question is asking if one string can be, or we can ask this way, the longer string, if a substring is removed, not substring, the longer array, if a subarray is removed, can it be identical to the other array? That's basically the question. Oh, also this is not right because you have to insert both and that's not allowed. Has to be a single. This is true. Oh, the constraint is only 100. Oh, that's very easy. Right? 100 is easy. So we can even brute force it. Yeah, O(n) tripled. No, not, yes, O(n) tripled. That's kind of the naive solution. You get like 1, 2, 3, you get the window bigger and bigger, right? And you remove it and try to compare if the two are exactly the same. All right, we have to use some other ways, either to make the comparison easier. Oh no, it's the same. Oh my god, it's actually not that complicated because you already know what's the size to remove. Because the smaller you have it, right? The smaller you have it, you know what it is. In this case, the longer we have size 4, smaller has size 2. So you know the window need to be, or the subarray that needs to be removed must have size of 2. So you just run a sliding window of size 2 and just remove it, and then we check if they're the same, right? If they're the same. All right, so can we have a method to make the check faster? I think maybe something like I'm gonna say like a rolling hash. You can make it easier if you can create a hash function for this, but if not, then we have to compare. You know what? I don't. Let's try something else. What if we use, let's say, 2 pointers? Okay, one pointing to the longer sentence, one pointing to the smaller sentence. Okay. So for one, we know sliding window will work. Sliding window will work, and it will run in O n times n. Right? It will run O m n, and it will definitely work. So what I'm trying to do now is to see if there is another approach. Let's say we have 2 pointers, so one pointer sentence 1, one pointer sentence 2. And if they're not the same, and then we say sentence 1 is the longer one. If it's not the same, sentence 1 will move forward. Until they're the same, then we start to wait, hold a second. That's, yeah, if they're the same, then we move forward, then, so yeah, it's the same, right? And then we keep matching until we cannot match. I don't think so. I think it's sliding window, yeah. I'll just do sliding window. I feel it is just sliding window. Maybe it's a better way, but sliding window definitely can get it solved, and that's all we want today. Let's get it solved. Alright, sliding window. So oh. That's a larger equal to. L equal to. Oh, don't say L. We say char. L equal to sentence. Oh no, not char. Bless you. List string. Alright. So a sentence 1 dot split. I think we can do this. And then we say s equal to sentence 2 dot split. Else. Okay, so now we get these two done. One is longer. Oh. It has to be this. Cannot convert this to. Oh, really? Oh, it turns into an array. Like this. Oh. And oh my goodness, so basically all of these has to be this. Okay. Alright, so now what we need to do is we go through the long one, right? And then we say int I equals 0 for int j equals 0, actually no, I know the length already. So j will equal to L long small dot length yeah, I want it to be the end, so this should be this -1. Alright, and then j smaller than long dot length j plus. Okay, so now I have I and j. Then we need to see, because oh wait, hold a second, that is not right. It shall be L dot length minus this minus S dot length -1, because long minus small, that is the window size, right? That's the window size. Okay, so basically we say from I to j is going to be removed, so from j plus 1 all the way to the end we need to try to match, right? We need to try to match, and I need to write a function called private boolean match. We say string s1 string s2, right? And also I1 j1 I2 j2. Okay, so basically let's say compare s1 I1 to j1 plus 1 plus s1 I2 to j2 equal s2. Okay, now we say for int I equal to I1 j1 and this, so we need I don't have to go I1 j1 because I only need I1 and I2. I don't need a j. So basically this is gonna be I1 plus 1, right? And then I2 towards the end. Okay, so for I equal to 0, I smaller equal to I1, I plus plus. So if S1 I is not equal to S2 I, I'm probably going to say string dot equal, oh, doesn't have dot equal, there we go, S1 S2 I. Right, if these are not equal, return false. Right, otherwise we keep going. So yeah, Done. And then for int j will equal to, because how do we go to I1, right? So I1 plus 1, right? And for int I equal to I2, I smaller than S1 dot length, I plus plus, no, I plus plus. Say if not equal to S1 I dot equals S2 j plus plus, also return false. Alright, the j needs to move forward as well. If both, then we'll return true. Okay, so I know j, so I the start is actually going to be -1. Actually, no, I is 0. Alright, I is 0. So we can say if match S1 is longer. Is no shorter. So long, short, I1 should be I minus 1, right? Should be j plus 1. If they match, then we return true. Otherwise, we return false. Okay, take a look. I forgot I plus plus. Alright, so we say sliding window. Sliding window. We know the size of the window, so we try each window, right, and compare whether the remaining words, if concatenated, are form a sentence that is equal to the smaller sentence. Each window on the longer sentence, and compare whether the remaining words, if concatenated, yeah. Oh yeah, man. Alright, so we're ready to submit this, but I think I want to, just maybe try one more thing. My name is Haley, so I can say, let's say, is Haley, right? This is the end, or I can say my name. Or my Haley. Yep, I think we cover all three scenarios. Any edge case? We have not tried single letter. Maybe we should try single letter. Single words like my, your work. It's another fail. Yep. Alright, try this. Huh. That is strange. Because there's no... Ooh. Index minus 1. Oh, because it comes in as a minus 1, right? So what I1 should be the one front. I equals I2. How is it possible minus 1? Who gets to be minus 1? Oh, I think here. That's not, it doesn't make any sense. Because I said all right, let's try it again. This is a bit weird. I guess we can print out every time we call it. We just kind of see where it is. Yeah. I don't understand. Alright, I got L1, L2, and that's I1, I2. Let's run it quickly. Both are -1. That is weird. Alright, so we have... Oh, the length is the same. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. That is not true. J shall be 0. I don't understand. How come I2 is -1? Huh? That's weird. That should be 0. -2? What? Something wrong with the split. Oh my god. Something definitely wrong with this. No, it looks good. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Oh shoot. Okay, I know what went wrong. Oh my goodness. Did I now consider this? Absolutely. I was completely blind to this. Oh my god, this is pretty bad. Yeah, this is pretty bad. I completely forget about this. If L is smaller than S dot length, right? Then we just swap them. We say string this temp equal to L, and we say L equal to S and S equal to temp. Okay, yeah, all right, that's pretty bad. That is pretty bad. Wow, I didn't realize that. I was using the wrong metric to evaluate this. Should be after you split, right? It should be after you split. I'm surprised that the other test cases pass. Yeah, but sometimes this type of thing happens, right? This type of thing happens. So I guess we can say that this week is all sliding window. I think this is like the third problem with sliding window that we do. Not complaining. I think sliding window usually is not that hard, so it can build up a lot of confidence. Deck. Oh, deck. Oh, I wonder if my template comes as m plus n instead of m times n. But you have to go through m, and each time you go through m, you have to go through n. But we scored pretty high, so I'm not sure what happened. Because this is definitely not OM plus N. I'm comparing them. Yeah, okay. What is this deck solution? So deck, comparing prefixes or beginning of strings. If the same, we can pull. So if the pre is the same, then we just pull. Compare the suffix. Oh. Damn. Ha. Okay. That is, how should I put it? It's pretty smart. Wow, but how is this one score so fast? I think it's just because the test case is weak. Yeah, there is a much faster way. Holy crap. Alright, I didn't even realize it. I did not realize you can do... Damn, how did you not realize? We can use 2 pointers. One check the front, and the other check the back. Whenever mismatch happen on the front and the back, the middle part must be the potential inserted. Right? Potential inserted. Middle part must be the potential inserted element. Right. Then our job is to ensure that the smaller one must be consumed. Yes. Our job is to ensure that the smaller one must be consumed. Yep. Our job is to ensure after checking on both ends, the smaller string is completely consumed. So we do the same thing, string L sentence 1 dot split string sentence 2. Okay, I like this. If L dot length is smaller than S dot length, then we just return our sentence. We just do sentence 2 and 1. Done. Right. Otherwise, in I equal to, so L is longer, so I equal to 0. J equal to L dot length minus 1. So while I is smaller than L dot length I plus plus, right? If I should say IL IS. Right? If it is smaller than L dot length, and IS smaller than S dot length. If if LIL dot equals SIS, if they are not the same, break. Right. Otherwise, just say IL plus plus IS. All right, so we check all of them. When they come out, is the first one is not the same, right? Yeah, they come out. And then we'll go the other side. Yeah, so what they're pointing at is the first one is not the same, right? Then we go the other side, which you need to say JL, JS. Okay, so while J long is larger than I think I can say larger equal to IL and JS is larger equal to IS. Because they can equal. Right? They can equal. Yeah. And then if let's say L it's JL dot equals S JS, that will break. Otherwise JL minus minus JS minus minus. Alright, so once just go from left to right, compare. The first one they're not equal, we jump out. And from the other side, compare. The first that's not equal, we jump out. Right. So when we jump out, we know left to right is pointing to the first one that's mismatch. And the right to left, right? The right to left is also the first one that's mismatch. And if it's mismatch, it will get out. So and it also says if they're not equal, or jump out. Or actually what we care about is JS, right? That's the only thing we care about. So JS need to completely consume it, right? Need to completely consume it. So basically they're the same and they come out. So I have to make sure that JS is, when it comes out, it must be smaller than IS. If no, it must be smaller than, yes, the JS must come out smaller than IS by 1, right? By 1. So I say if JS, if IS minus JS is equal to 1, then that's true. Otherwise, it's false. Make sense? What if we can go all the way to the end? Let's say IL and IS, and when we do, and it get out. Let's say IS goes to the outside, right? If IS go to the outside, then a while loop also doesn't run, right? While loop doesn't run. Then while loop doesn't run. That's actually not IS minus, it is IS minus JS. Yeah. So IS is all the way to the end, and JS is, well, this is actually gonna work, because IS is all the way to the end. Yeah, this is actually gonna work. Okay, let's try it. Give this a shot. I mean, we can use all the test cases we have used before. Let's see if it's gonna work. Looks good, and this I believe is OM, because, well, this takes M plus N, and this while loop, and this while loop go M times, so feels right. Well, it's the same, but it is faster. I mean, all we can say that the reason the two have the same runtime is because the test case is too small, right? Because it's too small, the benefits of ON plus N could not be manifested. Okay, that's it. Pretty good problem. All right, I'll see you guys tomorrow.